Assalamualaikum, my dear students. Hope you are doing well by the grace of Almighty. Welcome to our NIEVS Home School. This is Marjia Islam, Assistant Teacher of Science, National Ideal English Version School, morning shift. Now I am going to take a physics class for class 9. Our today's topic, Chapter 2 discussion, and our lecture number 11 and our homework number 9. Today is our last part of this chapter, our chapter name motion, and this is our third part, and this is the last part of this chapter. Now we start from page 49. We have mentioned earlier that the acceleration due to gravity is an example of uniform acceleration. The equation we have deduced about motion can be used to deduce the equations of motion of the falling bodies. In case motion S was used to indicate the travel distance. For a falling body, we will use h to introduce height. That means s is the travel distance and h is the height. For acceleration, we will use g instead of a. My dear students, you follow this. Here s is the indicate the travel distance. S means this is the distance, and h here this is indicate height. H means height, and here we use acceleration g instead of a. That means we use g instead of a. These two will be the only difference. These two will be only difference. We know v equal to u plus at. Here instead of a, now we can write u plus gt. Instead of a, we use here g, and same we can use, we know s equal to ut plus half at square. We know, but here we use instead of s we use h, and here ut plus half instead of a we use g t square. This is another one. And third one, we know v square equal to u square plus 2as, but here we use v square equal to u square plus 2gh. Instead of a we use g, and instead of s we use h. I hope you have understood, my dear students. Now the three laws of falling bodies of Galileo are knowing, but these equations of motion of falling bodies. The first law states that all objects released from the same height will reach the ground at the same time. It does not depend on the mass of the object. This does not go with the experience of our daily lives. If a piece of paper and a piece of stone are released from the same height at the same time, and then the stone reaches the ground first and the paper reaches the ground later, this happens due to the resistance of air. This is the important. This happens due to the resistance of air. I repeat, resistance of air. If the experiment is done in a vacuum tube, then both the paper and stone will reach the ground at the same time. Galileo's first law can be understood from the equation of falling bodies. This is because there is no mass of object in the equation of velocity and traversed height. That is, the acceleration due to gravity acts equally on both heavy and light objects. So the freely falling bodies traverse equal distance in the same time. The second law of Galileo is the law of increase of velocity due to g. If the initial velocity u is 0, then velocity v is proportional to z. Now Galileo's third law is nothing except the equation of height, that means h. In this formula, if we consider u equal to 0, then we see that traverse distance h is proportional to height. Now we go to the example. This is a math. Here example our problem. This is problem A good pitch of bowler of cricket can throw a ball with a velocity of 150 km per hour. If he throws the ball vertically upward, how high will it go? How high will it go? Now go to the answer. Here the given value. This is our given part, given value. This is, we can consider the given value. Given value here u equal to, this is the velocity u equal to 150 km per hour. Now we can convert kilometer to meter, then we multiply it with 1000 with 150 km. Now we can write 150 multiply 1000 meter, and this hour we can convert hour to second. That's why we multiply by 60 into 60. That means we know 1 minute equal to 60 seconds and 60 minute equal to 1 hour. That's why we can write. Then after calculating this, we get our velocity u equal to 41.67 meter per second. Now acceleration due to gravity will act as retardation when the ball is thrown vertically upward. The ball eventually comes to a stop. If the height is expressed by h, then we write, this is the formula, v square equal to u square minus 2gh. Actually we know the formula v square equal to u square plus 2gh, but here the negative value, but because of this retardation, we use here the negative mark. Now here we consider, because of this is the ball eventually comes to a stop. That's why we can write v equal to 0. That means final velocity equal to 0. Then we here putting the value v equal to 0. Then we can write u square minus 2gh equal to 0. Now u square equal to 2gh. Now 2gh equal to u square and h equal to u square by 2g. This is the value. This h equal to this h. Now we putting the value of u and gravitational acceleration g. Then here our u's value is this 41.67 meter per second and g's value equal to 9.8 meter per second square. Now putting this value and after calculating this, we get the result 88.59 meter. The ball will approximately reach the roof of a 30-storied building. I hope you have understood this math. Now go to the next math. This math is your homework number 9. This math is homework number 9. Only this math is. Now go to the next math. Our question: when a spaceship revolves around the earth, then its speed is very high and is nearly 10 km per second. If a cannonball is fired at this velocity straight upward, how high will it go? Answer: let us try like with the cricket ball, only the initial velocity will be 10,000 meter per second instead of 41.67 meter per second. We can calculate this same to this. Now we can write 10 km per second equal to 10 multiply 1000 meter per second, because we can convert kilometer to meter. That's why we multiply 1000 with 10. Now we get the formula h equal to, this formula v square equal to u square minus 2h. Same formula is using here. My dear students, listen to me carefully. Here we use, at first we know, use this formula v square equal to u square minus 2gh. Now this formula, after calculating this part, we get the h equal to u square by 2gh. This same thing use here. Now here h equal to u square by 2g. Now here putting the value u, here u equal to 10,000 and g equal to 9.8. After putting value and calculating this value, we get the result 5102000 meter. And now we convert this meter to kilometer, then we get 5102 kilometer. Though it is felt that there is no mistake anywhere, but actually the answer is not correct. Listen to me carefully. Anywhere, there is no mistake anywhere, but actually the answer is not correct. This is because we have considered the value of acceleration due to gravity is 9.8 meter per second square. This is true for the distances near the surface of Earth, but if we go far from the Earth, the value of g will decrease when we reduce the equation v square equal to u square minus 2gh. Now then we consider that the value of g is not changing. It is not true for this problem. So what we have learned till now, the knowledge cannot be used to solve this problem. If we cannot solve it, there will be no loss, because if anything is thrown upwards with this high velocity, it will be burned due to air friction. Now go to the next topic. This topic is important. This is our graph and determination of velocity and acceleration at any time for a time distance graph. This graph part is very important. Motion and graph. We have deduced equation of motion. In the previous sections, we have analyzed the relation between distance travel, velocity and acceleration. The relation between distance travel, velocity and acceleration. In this section, we will analyze the same quantities but only by graph. We can have a kind of real feelings about different quantities of motion if we analyze them graphically. Here the table, this is the time, this is the distance. This is the time, this is the distance. We need to mention something here. Whenever we have discussed distance, travel, velocity or acceleration, we always considered a standard situation. We considered that when an object moves, there is no friction and the object does not lose its energy by any other means. That does not happen in real life. That is why it is not so easy to collect real data for distance travel, velocity or acceleration. For performing a real experiment, an air track is used in the laboratory, where an object is kept floating in an air layer so that no friction is present. To measure the change of position of an object with respect to time, electric sparks or electronic signals are used. We will not get such type of data in our daily lives easily. For now, we will consider that we have collected some data in this standard situation to use in our graph. Two sets of data have been shown in the table. Now, my dear students, look at the picture. The picture finding velocity, time from distance, time and acceleration, time from velocity, time graphs are drawn. Look at this picture here. This is the x-axis and this is the y-axis. My dear students, look at the picture. This is the x-axis and this is the y-axis. X-axis is time. Here we can write here time and here distance, velocity, acceleration. Y-axis here distance, velocity part and acceleration part, and the x-axis part is time. Here we can write 1 second, 2 second. You can hear this is the value of time. This is the value of time 0 to 5 second. So now we can here write 0, 1, 2, 3, 4, 5 second, and the distance here, the value of distance 0, 1, 4, 9, 16 and 25. Now here the y-axis distance 0, here we can consider 0 to 30 to get this distance. Now putting this value, then we can graph, we can get this type of graph. Here when we put 0 to x-axis and 0 to y-axis, then we get this point, and when we put this value 1, this is the one part, 1, this is 2, this is 3, this is 4, and this is 5. When we put 1 for time, and then this is the 1 for distance, y-axis, this is the 1 for distance, then this is the 1 point. Then when we put this 2 value, then we get here, this is the point of distance 4. And when we put this 3 second, for 3 second we get the point for distance 9, and this is the 4 second, for 4 second we get the distance 16, for 4 second we get the distance, this is the distance of 16, and this is the 5 second for time, and we get for 5 second we get distance 15. Then we consider here this point, this is the distance point of 15. Now here our graph is this type. The distance time graph of the first data set of the table is shown in graph. Here we have taken data in integer form. From the graph we will be able to find the distance of any time of 0 to 5 seconds. For example, the distance of the object in 2.5 seconds is approximately 6.25 meter. That means here 2.5 second, we consider here 2.5 second, here this is 2 and 2.5 second is this point. For 2.5 second we get the distance, we can consider here, we can get kind of 6.25 meter. Here this 6.25 meter. Now if we have a velocity versus time graph, from there we can find the velocity easily. Velocity of an object is the rate of change of its position. So we can see from the graph the object has traveled a distance of 0 meter to 1 meter in 0 to 1 second. Therefore the average velocity at this time, actually we know the average velocity equal to displacement by time. Displacement means S, time means T. Here the displacement, that means our final point to our initial point. Here our final point is 1 and our initial point is 0. Now divided by time, here the difference of time, our time is T. Now we can, after calculating this, we get the average velocity equal to 1 meter per second. We can use this average velocity for the mid time value of 0 to 1 second. Similarly, the average velocity within 1 to 2 seconds, then we can write the same type of calculation. Here the velocity 4 to 1 and 2 to minus 1. After calculating this, we get 3 meter per second. Now we can use this velocity as data for the time 1.5. That means here this is the velocity graph. This is the velocity graph. We using distance, we know velocity equal to the rate of change of distance. Now for velocity, now we can find the velocity here. Here the velocity 1.5 within 1 to 2 seconds. That means within 1 and 2 seconds. Here our first velocity 1, this is the 1 second, this is the 2 second. But here our velocity is, this is 1 point, this is 2 point. But here this 1.5 second within 1 to 2 seconds, this point is here, this point is 1.5 second. That means this is 1 second, this is 2 second, and this point 1.5 second. For this that now we get this point. I hope you have understood this point, girls. Similarly, we see the average velocity between 2 second and 3 second is 5. That means now you look here, this is 2 second, this is 3 second, and our midpoint is 2.5 second and our velocity is 5. Here this is our velocity, that means this is 5, this is our velocity, this is 5. Then between 3 and 4 second we get 7. Now they are 3 second and they are 4 second, and we get 3.5, and our this is the point of 7. This is the point of 7. Here I hope you have understood, girls. And 4 second and 5 second is 9 meter per second. This is 4 second and this is 5 second. Here the midpoint and the average velocity, this is the 9. This is the point of 9. Here that means 4 second, 5 second, and our velocity is 9. Our here velocity is 7. Our velocity is here 5. That means this point, this is 5 point, this is 7, and this is 9 point. We see these data points are on a straight line. You see here this data point is a straight line. Although we have put the data for time 0.5, 1.5, 2.5, 3.5 and 4.5 second. You look here, here this point 0.5, here 1.5, here 2.5, here 3.5 and here 4.5. Our this value of timing, this is the time 4.5 second, but we can find the velocity at any time after drawing a straight line through these points. For example, at 3 second the velocity is 4 second. We can find, I repeat, a straight line through these points. For I repeat, but we can find the velocity at any time. At any time, not this fractional time 0.5, 1.5, 2.5, 3.5 or 4.5. This is not this fractional time. The velocity at any time after drawing a straight line through these points. For example, for 3 second we can get this. For 3 second, the velocity will, then we upward, the velocity will, that means the 6. I hope you have understood this part. For example, time 3 second, the velocity is 6 meter per second. Now go to the next part. We will be able to find the acceleration in the same way after drawing the velocity time graph of figure. Acceleration is the rate of change. I repeat, acceleration. What is acceleration? Acceleration is the rate of change of velocity. That means the rate of change of velocity. Velocity was the rate of change of distance, but displacement, but acceleration is the rate of change of velocity. Since the velocity time graph is a straight line, so in this case we will get the same value of the acceleration at any point on the graph. For example, the rate of change of velocity in between the time 2 second to 3 second is a equal to, we know the acceleration is denoted by a, and we know the definition of acceleration equal to the rate of change of velocity. That means final velocity minus initial velocity by time duration. Here we put in the value of 6 minus 4 and 3 minus 2. Now we get 2 meter per second square. For any other time, if we calculate the acceleration, the same value will be found. It is shown in the acceleration time graph in figure here. This is the graph. This topic is important. I hope, my dear students, you have understood our whole topic. Basically this 2 math and this graph. And our homework number, today's homework number is 9, and our homework 48 page, this math, only this math. But our chapter rest topic is our practical topic, so we can avoid this. And I hope you have understood today's topic. See you again in the next class. Till then, Allah Hafiz.